And when you deliver for a company, they keep coming back. It's exciting because you get to do something that really you see immediate impact. And that's kind of the difference between being an engineer and being a scientist. I like to joke that scientists like to understand God's mind, and engineers say, screw that, we're going to play God. So we don't want to understand what is going on. We want to create something that doesn't yet exist.
That was Josh Summers, a professor at Clemson University. In this episode of the podcast, we speak to Josh and another professor named Laine Mears about the skills gap again in engineering and manufacturing and some of the tools that they're using to help solve it. They've built a program called the Center for Advanced Manufacturing, where they work with large organizations like BMW, Michelin, Samsung, and you name it on their capstone or senior projects. And they've really come up with some unique and innovative ways to really help to solve the skills gap in engineering and manufacturing. So we have a great dialogue between the three of us on this particular topic. Hi, my name is Bassanio Peters, and I am the founder and CEO of Assist to Develop and the host of the Grinding Gears podcast. Super excited for this episode today. We have Laine Mears here with us, and then Josh Summers. Josh, say hello and introduce yourself.
Howdy. My name is Josh. I am a professor here at Clemson University in mechanical engineering. Been here for about 17 years and have been focused on trying to figure out how people design, how they should design better, and how can we develop new tools to design. And that has led us into trying to figure out how to bring design and manufacturing closer together.
Laine, same question. Can you tell me a little bit more about your background and experience?
My name is Laine Mears. I'm the BMW Endowed Professor of Automotive Manufacturing at Clemson's Automotive Engineering Department. This is a graduate department that we built about 10 years ago that centers on the automotive industry and providing graduate students for the automotive industry. It's really a systems engineering type of curriculum, but it uses the vehicle and the automobile as a platform for understanding the concepts that we're teaching. I've been in the automotive industry myself about 25 years. The first half in suppliers for automotive, and the second half as an academic, going back to school and teaching the concepts that I had difficulty with, problems that I had in the working world, and coming back into an engineering context and being able to teach those things from a standpoint of understanding them very well.
Awesome. Thanks for sharing that. Can you tell me a little bit of kind of your background and how you got started as an engineer? Like primarily what I like to ask on the podcast, is what is the thing, or what was the moment, if you remember the exact moment when you knew you wanted to get into the engineering space, when you knew as a kid that this was something that you were passionate about and you wanted to pursue? Can you talk about that moment briefly?
Sure. I've basically always wanted to design and make things. I am not a very good hands-on maker. I'm definitely not a mechanic. But back in first grade, I knew I wanted to be an engineer. Part of that was my uncle was an engineer. And then in fourth grade, I figured out that it was called mechanical engineering. And in sixth grade, I started doing science fair projects where we built wind tunnels and looked at how lift what resulted from different angles of the airfoil flaps. And then I kept doing that all the way through high school. And I could never actually escape the family curse. I knew that I wanted to be a mechanical engineer, but I also knew I was going to be teaching. And so I figured I'm going to be a college professor. Before I was in high school, I just admitted that that's where I was going to wind up. And along the way, I enjoyed working on a lot of projects with a lot of other people. And so collaboration was always what I thought was a driver behind getting stuff done, but it was also the thing that drove most people crazy. And it was through frustrations on different teams that led me eventually to where we currently are in trying to understand how teams work together and how they don't work together, especially when it comes to early stage design, looking at requirements, looking at functions, looking at concept development and stuff like that.
So one of the questions I always like to ask is, what have you learned through painful experience that you wish you could have learned earlier on? And it sounds like you're really focusing on collaboration and the importance of that. Is that something that growing up you didn't realize, through your studies as wanting to become a mechanical engineer, as you said? Is that something that you didn't realize would play as much of a role in engineering as you thought it would?
Yeah, I mean, most of the time when you go through your undergraduate curriculum, you have your individual assignments, and it's not until your senior year that you finally get to experience some teamwork and collaboration. And we had done in high school different academic competition teams and stuff like that, but it was never really emphasized in the undergraduate curriculum until your senior design. And so you know that you're going to have to work with people. You know that, but you never are taught how to do that. And so that's something that we're trying to figure out now, beyond just looking at design, but how do you form teams, even with manufacturing on an assembly line and stuff like that, so that they actually act as a team? And how do you learn about that teamwork? Is it the best way to learn by doing? Is it the best way to actually have bad teams so you remember those experiences? And so that's something that anytime I talk to any of our students, and even from personal experience, bad team experiences stand out in how you addressed it, whereas good team experiences, you forget about them.
Yeah, that's a really fascinating point because in one of our other episodes of the podcast, we spoke to a gentleman named James Trevelyan. He's the author of a book called The Making of an Expert Engineer. And what he really was emphasizing is the importance of collaboration and how people really don't understand in their career, because exactly what you're talking about, right? Like you're going through school, you're doing all your individual projects. Your senior year, you have a team project, but collaboration in the context of working together with people and also knowing where to go to get the answers you need, because you're inevitably not going to be able to know everything there is to know. So how can you collaborate with other team members, work well and function well as a team to be able to get what you want to accomplish? So that was another interesting fact that came up in a previous episode of the podcast. So Laine, you have experience working actually in industry. Can you tell me how you made that transition from working in industry to teaching and why?
I was working in industry, and as a matter of fact, I started off making ball bearings, for as exciting as that sounds. I say that jokingly. It really was a very interesting first experience as a professional engineer, figuring out again how we can make these things to this level of precision. I'm talking like down to the micron, these precision ground components, and these things cost like a quarter, right? How do you do that, right? How do you make something so perfect and shiny and perfectly round and so inexpensive? So that was very, very interesting. I learned a lot in the bearing industry. I transitioned over to tier one automotive parts supply, working with different kinds of steering systems and engine parts and sensors and that type of thing. Again, learned a great deal about a number of different processes. So I became an expert. I'm holding my fingers up in quotes, expert in machining, heat treatment, hard machining, forming processes, injection molding processes, automated winding, automated assembly, and all types of testing and metrology and that type of thing. And then while I was working, I got a little postcard in the mail that said, "Hey, get your master's degree while you're working." And I said, "Hey, that sounds like fun." I was like, "Man, I'm going to be an old man by the time I get done with that." Followed right up by the thought, well, I'm going to be an old man anyway, might as well have something to show for it. And so I did an online master's degree at Georgia Tech. and found it a lot of fun and very applicable to the work that I was doing at the time. And then basically took the plunge and quit my job. Had a nice little nest egg saved up to sustain me through the rough years, which is really interesting. I had X dollars saved up, and I had all these engineering calculations that I had done to eat up those dollars by the time I get to the end of my program after 3 years or 4 years or whatever it was going to be. And when I got to the end of my program, I had like 0.9x dollars still left. I had adjusted my life, and so I think the fear of taking that plunge, you got the mortgage and the car payments and those types of things. So a lot of people get constrained by fear and don't take the plunge as a result of that. And so there's nothing to be afraid of. So you're gonna live, and you're gonna make things happen. So when I got done with my PhD, it was going to be go back into industry and do some pretty interesting work, or it was going to be go into this new area of academia that I can explore and sort of see what's going on there. But I didn't want to write papers. I didn't want to be sitting behind a desk and just publishing stuff, which was my impression of academia at the time. So I looked at 3 programs that had some really industry relevant research going on, and got hooked up with one. So got hooked up here at Clemson as they're moving forward with this new program in automotive engineering, and it was great. It was a great timing. It was a great confluence of my interests and abilities coming together with a whole new world, and the ability to work together with industrial partners and produce something really fantastic.
One thing that I wanted to talk about, though, that prompted me to reach out is the excitement behind your Center for Advanced Manufacturing program and the Thinker program. Can you tell me a little bit more about that and our audience?
And so that was where this idea of the CU, Center for Advanced Manufacturing, was really born. And then as the glue that binds it all together, since we're a university, developing new technology is part of the show, but the vast majority of what we do at a university, even with graduate programs, is really focused on education. I mean, our research is really just a vehicle to teach grad students how to do research. And so we are looking at developing some new educational programs that will focus on graduate and also undergraduate students at different levels through the CAM. So one example is the NSF NRT Thinker program that you mentioned. And that's one that Laine, Mears, myself, Amy Apon, Laura Stanley, and several others from the university have gotten together and looked at how can we bring the human back into manufacturing and truly bring it back to the point where the human is at the center of manufacturing. We would like to think of it not as automation, but as augmentation. And so we're looking at different things that includes how do we gather information from human associates as they're doing their activities, to how do you push information to the human associates. But we're looking at this also as a training vehicle for the future leaders of manufacturing that understand what the associates are able to do, and how do we get the community college students involved and brought up to speed on new technologies, yes, but also on how do you work with other people. And so while a lot of the NRT is focused on the research in the technology development, the educational components are really how do you get people to work with others. So we talk often about engineers needing to be leaders. We forget that in order for there to be a leader, there has to also be a follower. And so one of the things that we're looking at is how do you teach people followership, not blind, I'm going to do whatever you tell me to do no matter what, but intelligent followership so that you can push back and ask questions and but at the same time get stuff done.
So one thing I wanted to ask is you talk about the importance of the research you're doing being a vehicle to teach the students, right? The grad students in particular. How do you intend, or excuse me, how has the research that you've done on automation, because you mentioned the point, it's augmentation versus automation. How have you discovered that augmentation is actually a better approach to manufacturing? Because the big talk these days is all about automation, robotics, the fourth industrial revolution, etc. Why are you guys putting the human back at the center of manufacturing when it seems like other people in industry are really focused on automation? What has your research told you?
We've done a lot of work with BMW over the last decade and a half, and BMW here in South Carolina, fantastic manufacturer, probably the number one exporter of vehicles from the United States. But they, let's say they make 350,000, 400,000 different vehicles a year at our plant. Of those, 400,000 are different. So there are no two vehicles that are exactly the same. And so you have a lot of variability and a lot of uh, differences in each vehicle. Every body is actually what they call a snowflake. So even though you try to automate the welding cells and everything is going to come out slightly different. And so you require a lot of on the fly, slight adaptation to ensure high quality. And that's actually where the human can be great. So as we go, humans are able to handle lots of different decisions on the fly. They're able to adapt a little bit to uncertainty. And then toss on top of that, BMW has over 15 million possible configurations for the X3 and X5. But they wind up having a new configuration offered every 2 weeks. And so they're constantly making all these changes. And if you had a purely automated system, you'd have to retrain all of your robotic systems constantly. Whereas humans are pretty good at learning. So we have the flexibility of humans, we have the decision making skills of humans, we have the learnability of humans. But one thing that we're sometimes forgetting is the excitement and motivation of humans. And so, how one of the things that we're trying to figure out is how do we get the assembly line associates really passionate and excited about different things that they're doing. And as an example, Corvette, when they're making the Chevy Corvette, those that are making the engines for the premier models actually get to sign their names on the engine block. Think about that. You're working on an assembly line, you have a product that's coming out, and you know your name is literally on that product. Do you think you might take some pride in that? So, what are some ways that we can help BMW put the names in the vehicle so that every time you drive down the road, you see an X5 go by and you go, I was part of that. I did that. I have that experience all the time when I look at LinkedIn and all my grad students and former undergrads get a new promotion. I can say, hey, I did that. Now, how do we get that to the associates?
Can you tell me a little bit more about, I know you guys are doing an event next week on October 9th on a vision for manufacturing in the region, a framework for competitive growth is, I think, what the title is called. Can you tell me a little bit more about the event, who's in attendance, what big companies are in attendance and coming down, and why is it a big deal for the region, particularly in South Carolina, but also that whole corridor? Why is it such an important project and actually event that you guys are putting together?
This event on November 9th, this Vision for Advanced Manufacturing in the region, is a very high-level workshop and panel session that's going to involve the president of Clemson, the president of BMW, the president of Bosch North America, and a number of other high-level participants to really lay things out on the table and say, here we are, 2018. These are the things that are important to us as organizations and as manufacturers in South Carolina and in the nation. What do we need to be working on? And we call it this framework for competitive growth. So what are the innovations that we need to be going after, and how does that tie into our economic prosperity? South Carolina is a manufacturing heavy state. So our manufacturing industry is about 50% larger than the rest of the country. And we need to focus on that. And we're putting a lot of efforts into that. The state is investing in manufacturing. The universities are investing in manufacturing. The national government and industries are all investing in manufacturing in South Carolina. And this is a checkpoint to say, are we working in the right ways? Are we working on the right innovations? We have held workshops like this before on a smaller scale and brought industry leaders to the table and said, what are the things we need to be working on? And the interesting thing that I found, and it completely changed my attitude about what's missing in manufacturing at the time, was we were all prepared with our PowerPoint presentations about all the great machines and models and simulations that we had, and we were going to show everybody, all the great stuff that we could do for them. And the conversation invariably would turn to, that stuff's really cool. We're really happy to see those kinds of technical innovations, and those are necessary, but we want to talk about people. We need people, and not just workers on the floor. We need people on the floor with new skills and new understanding about these new machines and all these great innovations that you're bringing to the table. We need people that understand those things, so when they come out on our floor, they can run them and they can have ownership of them. But we also need engineers. We need researchers. We need managers that have an understanding of the technical interactions that are going on the manufacturing floor. And we don't see a pipeline of those people big enough to satisfy us. This has been a revelation to me starting 6-8 years ago as I was talking with a number of different industry leaders. And now it's come full force around, and everybody is realizing this, that we have what's become known as the skills gap in manufacturing. You cite a Deloitte study that says we're going to have 2 million unfilled jobs. Maybe not so desperate and panicky as that sounds, but we're going to have 2 million jobs that could use better people in them, or people that have a better education or a better understanding about the things that they're working on. So we call these maybe underfilled jobs, or opportunities for improvement of the skills that are underlying these jobs. And it's really scary because the ability for the U.S. to create wealth through manufacturing is tied directly to the people that are driving that ship and making that thing happen. And so we can look to other countries that are competitors of ours in manufacturing, and we see the intense amount of investment that's going on there in building not only technologies, but building a people base on a very large scale to support these things. And so this is the message that I expect to come out of this workshop on the 9th, and very strong.
Thanks for sharing that. We had a conversation before the podcast where we were talking about some of the real world examples, because again, the event is great. You're going to hear what each of these large organizations' vision for advanced manufacturing is, but that's again an event where they're sharing this information and talking about the future. But one thing that I was excited when we were talking on the phone about is some of the actual work that you've done, for example, with like NASA and Michelin, where you've gone out and done some research at the organization and then gone back and worked with some of your students to come up with innovative products ideas. Can you share that story? Because I thought it was very impactful to show, hey, look, this is how we are directly solving the skills gap that exists in engineering and manufacturing. It's not, lip service. It's, hey, here's some of the stuff that we're doing. So can you share a little bit about those projects that we talked about on the phone?
Sure. So I think we were chatting about the Michelin wheels, so the non-pneumatic tire that Michelin has developed, and it's now on the market for skid steers and off-road vehicles. But this was about a decade ago where JPL was working on a lunar rover. And by rover, I mean a giant Winnebago for people to move around in. And they needed something that looked like it would work in space for a tire. And so they reached out to Michelin, and Michelin said, well, that's cool. We don't have money to develop a dedicated, but we can send a faculty member out to spend some time. So I went out to JPL and I worked with them trying to understand what their project needs were. And then, quite frankly, this is where everything started happening. I came back with a senior design project that Michelin sponsored for probably about $10,000. And we developed using undergraduate mechanical engineering design teams, developed some solutions for the non-pneumatic tire. So they were all supposed to be metallic based. So all of the tires they designed and built were deformable like a regular tire, but they were made out of metallics, which could work on the moon. And out of that, the student teams, I didn't get it, but the student teams each, I think there were 4 patents that came out of that. And then that led to a bigger project with JPL and another bigger project with NASA. And then that led to another bigger project with the Department of Commerce and NIST, where we were looking at using that same concept to try to push low rolling resistant tires for passenger vehicles and for larger trucks. And so, that's just one example of how we do projects with companies so that we can understand, how they do design. Other, we work very closely with TTI, a local company that no one ever heard of, but they know of their products. So Rigid, Ryobi, Oric, Milwaukee, Power Tools. These are the things that one of the local companies here designs and builds. And we've spent a lot of time with them on developing new products, helping them reduce the noise of the air compressor. But along the way, the grad students might discover a new research topic. So how can you tell the difference between people's backgrounds based on their preferences when they're choosing different concepts? And we actually now have a way that we think we can do that. And we are working with a colleague at NC State trying to build that into a more systematic method. At the end of the day, our target is to work with companies, understand what their problems are, and then along the way, listen to all the other pain points and see if we can't help those on the side, if you will. So the research is really defined by the grad students to help bigger picture problems, but they're get paid to work on the projects for the companies. So my grad students always wind up with 3 part-time jobs during grad school. You got classes, you got your project, and then you got your own research.
That's amazing. And something that is sticking out to me is, and I want to kind of ask you about, early on when you first started doing this, how shocked and surprised are the organizations when you guys come back and say, hey, we have a solution to this problem? And they're like, holy crap, this is actually really good. How often is that happening where the organizations are, obviously initially when they first work with you, they're like, yeah, here's this project, here's an issue that we have. When you were first getting started, were they not reluctant, but were they more like, okay, we'll see how this goes? And then now they're coming to you guys because they understand that you're going to deliver results. Can you tell me a little bit about that?
So, yeah, I would say that for the senior design program, Clemson has actually had a long history of doing projects for companies. When I arrived here, they had been doing it for 25 years plus, even before me. But one thing that we did is we shifted and told the students, I expect actual physical solutions. I don't want a paper solution in a semester. I want a built, functioning solution within the semester. And guess what? The students are able to do it. So every time you move the bar up for the students, they're able to deliver more. And so while I don't think the companies were surprised that we were able to help, I think they were very excited that we were able to help and have come back more and more and more. I mean, I don't know how many projects I've had with BMW now in the last 13 years, 14 years, but it's probably in the scores. And when you deliver for a company, they keep coming back. It's exciting because you get to do something that really you see immediate impact. And that's kind of the difference between being an engineer and being a scientist. I mean, I like to joke that scientists like to understand God's mind, and engineers say, screw that, we're going to play God. So we don't want to understand what is going on. We want to create something that doesn't yet exist. And working with companies gives you that chance every single day. And you're always having to find new ways of solving their problems. And quite frankly, we're never given enough money to solve the problems the way we think we should. So we still have to solve them. We just have to do it with a lot of thrift and frugality.
What's really exciting to me and what's standing out is, again, in my career, I've heard about the skills gap in engineering and manufacturing that exists. And a lot of organizations that we talk to say, hey, look, there's kids that are understanding theory, but they don't know how to make a physical manufacturable project. So for you, you're telling these students early on, like, hey, look, for your senior project, I don't want a piece of paper. I want to actually physically manufactured and built product. And I think that's really the difference with, obviously universities like Clemson and other ones out there that are doing this. Because, I spent some time working in the oil and gas industry in Texas, and I knew one large organization only recruited from one of the schools. I won't name the school versus the other because the lead engineering manager was like, hey, look, these guys at this school are really only learning theory. So they come in here and we got to teach them the hands on, where this other school really focuses on the hands on expertise and experience. So obviously, Clemson has a history of this, and you guys are continuing to push this forward, which allows these students to get that real world experience. And one thing that I wanted to ask you is, as best you can, describe the feeling the students get in the grad program when they finish that senior project, especially the ones you were talking about in the past, where it's something that's patentable. Can you even describe the sense of pride that these students are feeling when they complete these projects?
I would say it's kind of like giving birth. I mean, they hate it when they're going through the delivery, but afterwards you have a fantastic glow about you. And then to the point where you forget how painful that delivery was, you might actually go and have a second child. Maybe that analogy is not appropriate for 22-year-old mechanical engineers, but I think there is something to that. And quite frankly, to try to capitalize and build on this even more, one thing that we're looking at through the Center for Advanced Manufacturing is to develop a advanced manufacturing focus program for our mechanical engineers, where they can spend 2 years, their senior year plus 1 year of a master's program up in Greenville, where instead of doing one capstone design project, they're going to be expected to do 4 different capstone design projects, all of them for different aspects of manufacturing with different companies. And so rather than having one baby at the end of their program, they're going to have 4 kids.
Laine, what else do you think educators can do to help prepare students with industry experience and relevant experience as they prepare for the fourth industrial revolution, or as people are calling it, Industry 4.0?
In preparing students for the new industry, for what we might say is Industry 4.0 or the Internet of Things or the industrial Internet of Things, we as educators need to have a good understanding of that ourselves. And let me tell you, there is not a clear definition of these concepts that are floating around, this Internet of Things or smart manufacturing or digital manufacturing. Everybody has their own flavor and everybody has their own interpretation of what that is. Some of the things we're trying to do at Clemson is distill some of those ideas and create demonstration areas and models of those ideas that we can take somebody to and say, okay, this is a little microcosm of what smart manufacturing is, and this is how we use it to leverage profitability for manufacturers. One of the areas that we're concentrating closely on is the integration of people to the manufacturing enterprise in this new digital age. So how do we use people to generate information, not just through typing something into a computer, but maybe automating the generation of information from people? And what are effective ways to feed information back to people, keeping in mind that people are different and the solution for person A might be different than the solution for person B? And how do we use that to drive new designs of manufacturing systems? It's a very interesting topic, and it's a very interesting time to consider it because we have the world to win as a result of really understanding how we can design the next generation of manufacturing systems, coupled with how we can include people in the next generation of manufacturing systems, coupled with how do we educate people about the technologies that support the next generation of manufacturing systems.
I think you guys are doing a phenomenal job. And as we start to wind down, obviously not everybody has these types of programs in place, right? Not all these different institutions across the country are doing this, but I think there's a large rise to, I'd say, consciousness where people are really starting to understand, like, hey, look, for America to be competitive in the future, we need to invest more in our youth, especially in, STEM related fields, mechanical engineering being one of them, and manufacturing. What else, in your mind, can educators do to help prep these students with more industry related experience? You guys have a model that works really well, but if someone doesn't have the same amount of resources that Clemson does, what would be your advice to an educator in that position to put their students in the position to be as successful as they can with a limited number of resources?
So, one thing I would do, and let's kind of roll this back into a little bit before college, even. We need to bring shop classes, industrial arts classes back to the high schools and make it known that this is an important thing. Being able to know what a wrench is for an engineer, it's actually an important thing. Secondly, in high school, we need to convince everyone that they need to learn to write more. So we need more writing classes, more literature classes, more public speaking, communication classes. This is something that it's a dirty little secret, but engineers write more than any other discipline out there. We write more than newspaper editors. We write more than novelists. Because if we have an idea, we have to communicate it both to ourselves in the future and then to others. And an idea in our head is worthless until it's put to paper. So I think writing and shop early is critically important. Now, going into the universities, there are companies around every single college town. And you need to know those companies and reach out to them. And I have not found a single company that I visited about doing a senior design project that did not give me a senior design project. And it's not about price point. Some schools charge $1,500, some $10,000, some $50,000. What you're doing is you're trying to find the experiences for the students, and it's definitely doable and possible. We do it, and there's nothing magic in our sauce. It's a matter of getting out of the college campus and getting off campus, knocking on doors, reaching out to alumni and saying, hey, can you help us? And everyone wants to help. So I guess it's about taking blinders off.
That's a good way to describe it. As we wind down here, one of the last questions I always like to ask is, if you could give only one piece of advice to the next generation of engineers and innovators, what would it be and why?
All right. I would tell everyone, the same thing I tell my daughters when I drop them off at school. Work hard, learn lots, have fun, and be good.
Laine, same question to you. What is one piece of advice that you want to give the next generation of engineers and innovators? If it could only be one piece of advice, what would it be?
In sharing advice with the next generation of engineers, if I was looking at just one thing, it would be a very non-engineering answer. I would say that ideally, learn how to communicate and support one another. This is a huge, huge issue in engineering. People think engineering is about technology and modeling and equations and building things. Engineering is about communicating with other human beings. I just returned from a big workshop at the National Science Foundation, and it was about a new project that we're starting. That's a convergent type of research project. It's bringing together fields of manufacturing and mechanical engineering and industrial engineering, computer science and psychology. And there wasn't a single talk at this workshop about the cool technological innovations from research. This workshop was completely about how to get people to communicate better with one another, how to understand who you're talking with, how to get your ideas across cleanly, quickly, and concisely, and how to be able to talk at an appropriate technical depth for the type of person that you're talking with. Are you talking with somebody in your own field? Are you talking with somebody in an aligned field? Are you talking with somebody from the social sciences that's never heard of what you're talking about before? And how do you communicate these things, not just with words? How do you write to these people? How do you present to these people? Even to the point of how do you do videos and how do you use improvisation techniques and acting and body language in a way that gets your point across. So I find the people, it made me realize this, that I find the people that are really good communicators are people that are really successful engineers. And again, great thing about academia, I'm out of my comfort zone once more. My eyes are opened once again, and I think we got a new path to forge out on.
I think you guys are doing amazing things. That whole I-85 corridor, and I work with a couple companies in the area down there, and they rant and rave about you guys there at Clemson. They do some work with you guys. So appreciate everything that you educators are doing to really try and help solve the skills gap that exists in engineering and manufacturing, and programs like this that really push the students, because I think that was one of the points that stood out to me that you brought up. You're raising the bar, right? You're pushing these students outside of their comfort zone to, in your terms, create their baby, have their first baby. It's through trials, tribulation, tough experiences, and you hate the project as you're doing it. But again, you described it as having a baby and giving birth to something. That's truly what you're doing as a mechanical engineer. So again, I really thank you for your time you spent with us today, and looking forward to staying connected and seeing what's next.
Yeah, sounds great. Thanks for having us, and check back in next year to see how all the new programs are actually flushed out.
We absolutely will. Thanks, Josh. Thanks, Laine. And we will catch you guys next time. Cheers.
Cheers.